All right, here are solutions to perfect problem 7 for Math 112. We're given 3 different problems here. So I guess tackle the first one. Basic idea is that this should simplify into something much smaller. This expression with lots of trig functions in here should simplify. So simplify it. And one strategy for doing so is to first replace all the trig functions, write them in terms of sines and cosines. So what I mean there is cosecant, that's the same as 1 over sine. Cosecant of x, same as 1 over sine of x. So I can write, instead of 3 over cosecant squared, I can write 3 over 1 divided by sine squared. Should write sine squared of x, I'm just going to write sine squared because I want to keep it a little bit brief. Even though it's bad notation, I'll do that throughout this problem. So instead of writing secant squared, I'll write 1 over cosine squared. And then on the bottom here, I got 1 plus cosine divided by, and then again, instead of secant, I can write 1 over cosine. So just replacing all the non-sine and cosine trig functions with sines and cosines I get here. And then I can simplify that. Let's see, I could do a few things. Up top, if you think about this as 3 over 1 and 2 over 1, then I got a fraction over a fraction. And the way you divide fractions is kind of like multiplying, but you multiply by the reciprocal of the denominator. If you multiply by the reciprocal of the denominator here, you'll get 3 sine squared minus, and then over here you'll get 2 cosine squared. And then down on the bottom here, let's figure out what we have inside the parentheses. On the top of my fraction, I got 1 plus cosine. And on the bottom, I have a fraction. So up top, I'm going to write 1 plus cosine over 1. And on the bottom, I'm going to say, well, let's see, I can think about this one here as 1 over 1. And I want to make this all one fraction, so I need a common denominator. So instead of 1 over 1, I'll think about it as cosine over cosine. And what that'll give me is cosine plus 1, all divided by cosine. Which I can then simplify. I'll leave the top alone. 3 minus 3 sine squared minus 2 cosine squared. But on the bottom here, if you flip this over and multiply, the 1 plus cosines will cancel out, and you'll be left with just cosine inside the parentheses. But then what's inside the parentheses is supposed to be squared. So I get cosine squared down on the bottom here. Which I can then simplify further. Let's see, a trick that'll be kind of handy here is viewing this as 3 minus sine squared. If I take out one of the sine squareds, I'm left with, well, I'll write it out. I don't want to skip too many steps. Minus 2 sine squared minus 2 cosine squared divided by cosine squared. So all I did there is I had negative 3 sine squared. I wrote that as negative sine squared minus 2 sine squared. Minus 1 of them minus 2 more of them is minus 3 of them. But the advantage of doing that is I can then write 3 minus sine squared minus 2 of these sine squared plus cosine squared things divided by cosine squared. And using the Pythagorean identity, this is just 1. So I got 3 minus 2, which is just 1. I get 1 minus sine squared over cosine squared. And then finally, 1 minus sine squared, that's the same as cosine squared, because you take this identity and you subtract sine squared from both sides, you'll get cosine squared as 1 minus sine squared. So this is just cosine squared over cosine squared, which is equal to just 1. So all that work, that whole thing simplifies to just 1. All right, and then on this second one, kind of the same idea. You could change everything into sines and cosines, although I think you can save a little bit of time by noticing that 1 over tangent squared is just, so let me write. This first one is saying negative cotangent squared minus 1 over tangent squared is the same as cotangent squared. So really it's just that times that. You could also change them into sines and cosines. It'll work fine, but it might save you a little bit of time to recognize that. 1 over cosecant, that's the same as sine. Tangent, that's sine over cosine. divided by, maybe for that cosine I'll write it as cosine over 1, so it's a fraction over a fraction. And then on the bottom, cosecant, it's 1 over sine, minus cosecant again is 1 over sine, times 1 over secant squared. Secant squared is the same as cosine squared. So we get to here. And then if you have a negative cotangent squared and you subtract another one, you got negative 2 cotangent squareds. And then we want to multiply that by, okay, so I'll leave this sign alone. If you divide these fractions by multiplying by the reciprocal of the denominator, you'll get sine over cosine squared. And then down here we already have a common denominator, it's sine. So we get 1 minus cosine squared all over sine. So we got negative 2, maybe I'll finally change this cotangent into cosine squared over sine squared. Because eventually I'm going to want them in terms of cosines and sines. And then over here, to get a common denominator, you'd have to multiply this by cosine squared over cosine squared. And you'll get sine cosine squared minus sine divided by cosine squared. And then down on the bottom here, 1 minus cosine squared. You can get a little fancy, use this thing. If you subtract cosine squared from both sides, you get sine squared is equal to 1 minus cosine squared. So I get sine squared over sine. So let's see what I have. Negative 2 cosine squared over sine squared times, might be helpful later to factor a sine out from those top terms. Factor out a sine, you're left with cosine squared minus 1. And then on the bottom I got cosine squared. So this just went here. And then you can multiply by the reciprocal of this thing, or you could, well, sure, I'll do it in the next step, I'll cancel. The reciprocal of that is sine over sine squared. But a lot of this stuff cancels. Maybe I'll go one. No, I'm gonna go one step further. Negative 2 cosine squared divided by sine squared times sine times cosine squared minus 1. Let's see, subtract 1 over here, and I'd get cosine squared minus 1. Subtract sine squared over here. That's negative sine squared. And that's divided by cosine squared. And then you got a sine and a sine squared. Now let's see what cancels. Cosine squared and cosine squared cancel out. Sine squared and sine squared cancel out. Sine and sine gives me sine squared, which cancels out with this guy. And the two negatives cancel out. So when all the dust settles, all I'm left with is 2. I did all that just to get the answer 2. So that was 1, this one was 2. Okay, and then the third one. Whew, tired. We can do that in kind of the same way we did the first two. Let's see, we got this cosine out here just hanging out. And then sine cubed plus sine cubed is 2 sine cubed. And then cosine times sine. And then to that we want to add 2 divided by tangent, tangent sine over cosine. So that is 2 cosine over sine times cosecant is 1 over sine, secant is 1 over cosine. So if you flip that upside down and multiply, you get cosine over sine. And then cotangent divided by sine. Let's see, cotangent is cosine over sine. So it's cosine over sine divided by sine over 1. Maybe I'll just write that. Don't try to do too much at once. Cosine over sine times 1 over sine. And then to that I want to add sine times cosine times secant squared, which is 1 over cosine squared. And divide that by the square root of 1, well, 1 minus cosine squared, that's just sine squared. If you subtract cosine squared from both sides of this equation, get sine squared. So I got the square root of sine squared, which is just sine. Okay, let's hold off with that cosine for now. We can cancel out this sine with one of these sines and be left with 2 sine squared over cosine. Over here, man, let's see, we got, okay, I'll write it out. 2 cosine squared divided by sine squared, that's what's up top. And then instead of dividing, I can multiply by the reciprocal. This is cosine over sine squared, so the reciprocal will be sine squared over cosine. And then to that, I want to add, okay, well, how to do this. This is just sine, so that cancels out with this. Right? The square root of sine squared is just sine. Sine and sine cancel out. Cosine and 1 over cosine cancel out. Just left with just 1 over cosine. Okay, I should be more careful if I'm going to screw it up. Sine and square root of sine squared cancel. And then I have, I'm going to write it. Get to there. Might be one more step than I need to show, but whatever, could help some people. Got 2 sine squared over cosine, plus these sine squareds cancel out, and I get 2 cosine squared over cosine. And then over here, these sines cancel. This cosine cancels with one of these cosines, and I get 1 over cosine. And I can now take this cosine and distribute it to all 3 terms, and I'm left with 2 sine squared plus 2 cosine squared plus 1. But that is 2 of these sine squared plus cosine squared things plus 1. But this is just 1 using our Pythagorean identity, so this is 2 plus 1. 2 plus 1 is 3. So I get my answers 1, 2, and 3 for these 3 problems. Woo, and that's finally at the end of this thing.